Indexable carbide drills do a fantastic job at going into interrupted cuts, even going into like an inclined surface or exiting on a rounded surface, even going into weldments. So with the indexable carbide drill, it's really the purpose of it is sometimes whenever you get into more difficult applications, you want to make sure that you are using an indexable carbide drill to be able to go through some of those more difficult applications. One of the things that we want to show you is the incline block that we have set up today. This is going to allow us to show you how it can perform very well in interrupted cuts in really any type of application.
So for this application, we're going to be running in a block of 4140 material. It's about 140 Brinell in hardness. The first cut that we're going to take is we're going to run an interrupted fly cut on this side of the part, and then we're going to come here and we will drill a solid hole, and then we're going to do about a 40% offset to simulate plunge milling, and then we're going to come up to the peak and show the tool doing a fairly extreme interrupted cut. All right, for this first application, we're going to do the fly cut on the side of the workpiece. The speed and feed we're going to be running is 750 surface feet per minute with a feed rate of 2.5 thou per rev. For this application, we're going to do a plunge milling operation where we'll drill 3 solid holes into the 30-degree incline, and then we will come in and do 2 more holes in between the 3 solid holes to make basically like a large pocket. So the speed and feed for this one is going to be 600 surface feet per minute and 2 thou per rev feed rate. For this application, we're actually going to drill into the peak of the incline, so it'll be a fairly severe interruption, and we're going to run this also at 600 surface feet and 2 thou per rev.
All right, let's take a look at the part that we just made and how we could actually apply this in maybe your situation. So how we came in, the part was on an incline, and we came in with the indexable carbide drill and drilled pretty much half of a hole here. This is a situation where if you're already end milling a flat surface to be able to come back in and drill, you can eliminate an operation of having to come in and end mill flat before you drill. You can just come in with an indexable carbide drill in one shot and be able to drill that hole, even coming in on an inclined surface. Up at the top, it's even more severe. So how you have 2 different angles coming in and you're coming in on a peak. This is a situation where if you've got any type of non-uniform part where, like I said, typically you would be end milling a flat surface and then you would come back in with a drill. This is a nice way that you can come in one shot with an indexable carbide drill, not have to mill that out with an end mill or a shell mill, just come in straight with a drill. Another situation is how we came in these 2 spots here and how we pretty much did a plunge drilling where we overlapped them. In a lot of cases, somebody would come in and remove a lot of material and do pocket milling with an end mill. You can come in with an indexable carbide drill and just remove majority of the material. It's going to be a cycle time saver for you. Come in, plunge drill, and then you would be able to come back in with an end mill later on and clean all that up. Instead of trying to do all of that type of work with an end mill, that would really take significant cycle time. This was very quick to come in, really remove most of the material for whatever the type of job is that you're looking at.